Hello students, happy morning. Class 12 Physics, Unit 1, Electrostatics Revision Continuation video. In our previous class, we discussed the book bag question from the subtopic Capacitor and Capacitance. Here some more questions are pending. Let we see by today. Our first question, that is question number 4, long answer question. Okay. Derive the expression for resultant capacitance when the capacitor are connected in series and parallel. Okay, we have to find the resultant capacitance of the capacitors that are connected in series and parallel. Okay, first of all let me see the series combination. Series, that means you know very well, that is connected, one end of the capacitor is connected with the other end of the capacitor. Okay, one to one connection, that is known as series connection. Okay, first of all we have to consider three capacitor here. Okay, having the capacitance value C1, C2, C3 that are connected in series with a battery of voltage V. Okay, then for this series connection you have to know only one thing. Okay, in series connection the charge in each capacitor will be same. Okay, but in parallel connection the potential drop across each capacitor will be same. Okay, here it is a series connection, so the charge in each capacitor will be same, but the capacitor having the different capacitance value, so the voltage across each capacitor will be different. Okay, here it is a series connection, so each capacitor have the same amount of charge, but the capacitor having the different capacitance value, so the potential drop across each capacitor will be different. Okay, but the applied potential is equal to the potential drop across each capacitor. Okay, so we can write the total voltage across each capacitor must be equal to the voltage of the battery, that is V is equal to V1 plus V2 plus V3. We know Q is equal to CV. We can write V1 as Q by C1 because the charge is Q here. The capacitance of the first capacitor is C1, so Q by C1. V2 is equal to Q by C2. V3 is equal to Q by C3. On substituting this expression we get V is equal to this one. Okay, then Q is constant, taking out of the bracket, then we get 1 by C1 plus 1 by C2 plus 1 by C3. Okay, then we know V is equal to Q by CS. Here CS is the effective capacitance of the capacitors that are connected in series. Okay, this combination is equal to this one. Okay, these three capacitors became a single capacitor having the capacitance CS. Okay, then we get 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, this can be defined by the statement as the inverse of the effective capacitance or equivalent capacitance. Okay, inverse of equivalent capacitance is equal to sum of the inverse of or sum of the reciprocal of individual capacitance. Okay, always the effective capacitance is less than the individual capacitance. Okay, see, to answer this question let me see the what are the important things needed. Okay, capacitors in series. This is a proper way of drawing the capacitor. Okay, two parallel lines that denotes capacitor. This one is capacitor 1 having the capacitance C1. This is C2. This is C3. Okay, these three capacitors are connected with a battery of providing potential difference V. Okay, so having the different capacitance value, but the charge of each capacitor, that means the charge stored in each capacitor will be same. So we can write the charge in each capacitor will be Q, but different capacitance, because of different capacitance, so the potential drop across the capacitance will be different. Here V1, here V2, here V3. Okay, but the applied potential is equal to the potential drop across each capacitor, so we can write V is equal to V1 plus V2 plus V3. Okay, we know Q is equal to CV. Okay, then V is equal to Q by C. Then we can write V1 is equal to Q by C1, then V2 is equal to Q by C2, then V3 is equal to Q by C3. Substitute in the equation 1. Okay, then we get V is equal to Q by C1 plus Q by C2 plus Q by C3. Okay, we know V is equal to Q by Cs. Okay, here C is the effective capacitance of these three capacitors. Okay, this is Cs. We can write Q by Cs is equal to Q 1 by C1 plus 1 by C2 plus 1 by C3. Okay, then we get Q going to cancel, then we get 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. We can write this expression as a statement, that is the reciprocal of the effective capacitance or reciprocal of the equivalent capacitance is equal to sum of the reciprocal of the individual capacitance. Okay, if suppose n capacitors of same capacitance that are connected in series, for that the effective capacitance will be 1 by Cs is equal to n by C. Okay, we need the Cs alone, then Cs is equal to C by n. This is the effective capacitance of the capacitors having the same capacitance that are connected in series. Okay, always the Cs is less than C1 or C2 or C3. Okay, always the effective capacitance is less than the individual capacitance. Okay, the next question, this is also a part of this question only. Okay, capacitor connected in parallel. Okay, capacitor connected in parallel, we have to find the capacitance. Consider three capacitors having the capacitance C1, C2, C3 that are connected in parallel like this. Okay, parallel means here 1 to 1 it is back to back. Okay, that is meant by parallel. It is connected with a potential difference provided by the battery V. Okay, here in this case it is a parallel combination, so the potential drop across each capacitor will be same. Okay, but the only difference is here the charge on the each capacitor will be different. Okay, in capacitor 1 the charge store is Q1, in 2 that is Q2, in 3 that is Q3. Okay, here the total charge applied by the battery is Q, then we can write Q is equal to Q1 plus Q2 plus Q3. Then we know Q is equal to CV, substitute here Q1 is equal to C1V. Okay, then Q2 is equal to C2V, Q3 is equal to C3V. Substitute in this expression. Okay, then we get Q is equal to C1V plus C2V plus C3V. We know Q is equal to CPV. Okay, substitute in this expression we get Cp is equal to C1 plus C2 plus C3. This can be written as the equivalent capacitance of the capacitors that are connected in parallel, that is equal to sum of the individual capacitance. Okay, here in this case the effective capacitance is always greater than the individual capacitance. Okay, see capacitor in parallel. Capacitor in parallel. Okay, for this we need to consider three capacitors. Okay, having the capacitance value C1, C2, C3. Okay, C1, C2, C3, these three connected with a potential difference V. Okay, for this case the potential drop across each capacitor will be same, V, because it is contained in parallel, but the charge in the each capacitor will be different, Q1, here Q2, here Q3. Okay, so the applied charge is Q, then Q can be written as Q1 plus Q2 plus Q3. Okay, we know Q is equal to CV. Okay, for Q1 we can write Q1 is equal to C1V, Q2 is equal to C2V, Q3 is equal to C3V. Substitute here, we know already Q is equal to CPV. Okay, Cp is a effective capacitance. This became this one. Okay, this is Cp. Okay, we can write Q as Cpv, that is equal to C1v plus C2v plus C3v. Okay, then we get Cp is equal to C1 plus C2 plus C3. If capacitors are connected in parallel, then the effective capacitance is equal to sum of the individual capacitance. Always Cp is greater than C1 or C2 or C3. Okay, if suppose n capacitors of same capacitance that are connected in parallel, for that case Cp is equal to Nc. Okay, our next topic, distribution of charges in a conductor and a action point. Okay, here let me see the book bag question from this topic. First question, that is a very short answer question. What is corona discharge? Okay, it is a leakage of electric charge from the sharp point of the charged conductor, that is known as corona discharge or action of point. Okay, the question is corona discharge, or it may be called as action of point. It is defined as a leakage of electric charge from the sharp point on the charged conductor. Okay, suppose I am having the charged conductor in this shape. Okay, here having the charge, the electric charge will leak. Okay, from this sharp point. This phenomenon is known as corona discharge or action of point. Okay, here I consider a conductor, that is charged conductor. In that there is a sharp point. Okay, at that sharp point the charge will leakage, that is known as corona discharge or action of point. Okay, let me see. If see in a conductor, in a charged conductor, the electric field near the sharp edge. Okay, at this point the electric field will be high. Due to this, air in this region, okay, that going to ionize. Ionization means there is a splitting of positive and negative ions. Okay, then the positive ions are repelled and negative ions are attracted by the this point. Okay, then this will reduce the total charge of the conductor. Okay, this is known as action of point or current discharge. This is a principle they are using in lightning arrestor and Van de Graaff generator. Okay, then next question, explain in detail how charges are distributed in a conductor and the principle behind the lightning conductor. Okay, first of all, this question is split up as two. First one is how the charges are distributed in a conductor. Okay, then let me see the principle behind the lightning conductor. First of all, we have to know the properties of conductor at electrostatic equilibrium. Okay, that is the basic of this question. See, for this we are considering a two conducting sphere, that is named as A and B. This A having the radius R1, B having the radius R2. Okay, the two conducting sphere are connected by a wire having the length L. That length will be greater than the radius R1 and R2. Okay, if suppose I introduce a charge Q in any of the sphere, okay, then the charge will be redistributed in both the sphere. Then at the next instant, the electrostatic potential in the charge A, and the sphere A and the sphere B will be same. Okay, here after introducing the charge Q, the charge in the sphere A will be Q1 and the sphere B will be Q2. Okay, we can state Q1 be the charge residing on the surface of the sphere. Okay, we already studied in the properties of conductor to electrostatic equilibrium. Okay, we know very well the charge in the net charge inside the conductor will be zero. All the charges must reside on the surface of the conductor. Okay, see, Q1 be the charge that reside on the surface of the sphere A and Q2 is the charge that reside on the surface of the sphere B. We know Q is equal to Q1 plus Q2. We know very well charge is conserved. Okay, the charges are distributed only on the surface. There is no net charge inside the conductor. This is a valid point. Okay, then the electrostatic potential on the surface of the sphere A. Okay, at this point we have to calculate the electrostatic potential. We know the formula V is equal to 1 by 4 pi epsilon naught Q by R. Here the charge on the surface will be Q and the radius is R1. So we can write V is equal to 1 by 4 pi epsilon Q1 by R1. Okay, then on the B, that is VB is equal to 1 by 4 pi epsilon naught Q2 by R2. Okay, we know last point of the properties of conductor to electrostatic equilibrium, that says the potential will be same. Okay, then VA is equal to VB. We can equate this. VA is equal to VB, we get Q1 by R1 is equal to Q2 by R2. Okay, here the charge density on the surface of the sphere, that is surface charge density, that is represented by symbol sigma. We know sigma is equal to Q by A. Okay, sigma is equal to Q by A. So we can write Q is equal to sigma A. Okay, for the sphere A, the charge can be represented as Q1 is equal to sigma A, that is sigma 1 A1. A1 is the area of the sphere A, that is 4 pi R1 square. Okay, then Q2 is 4 pi R2 square sigma 2. Then sigma 1 R1 is equal to sigma 2 R2. Okay, then sigma R is equal to constant. We can write sigma is proportional to 1 by R. If radius decreases, then charge density increases. That is the reason why the charge will leakage at the sharp point of the conductor C. For this, here the radius of curvature is small. Okay, we know radius decreases, then the surface charge density increases. Due to that, the charge will leakage. Okay, let me see the actual information needed to solve or answer the question. Okay, the question is how charges are distributed in a conductor. Okay, wrong answer. For that, we are considering the two sphere. Okay, this is sphere A having the radius R1, this is sphere B having the radius R2. Okay, these two spheres are connected by a wire. The wire having the length, this length is always greater than R1 and R2. Okay, then I am introducing the charge Q in any of the sphere. Okay, then the charges are redistributed. Now the two spheres are at electrostatic equilibrium. Okay, two spheres are at electrostatic equilibrium. Okay, we know the properties of electrostatic equilibrium, that is electric field inside the conductor is 0. Then there is no net charge inside the conductor. All the charges must reside on the surface of the conductor. Then the electric field will be on the surface of the conductor will be perpendicular to the surface. And the fourth point, that is the potential inside and outside the conductor will be same. Okay, after introducing the charge Q on any of the sphere, then the charge on the sphere A is Q1 and the sphere B is Q2. Then net charge Q is equal to Q1 plus Q2. Okay, then I am considering the electrostatic potential at a distance, that means on the surface of the sphere A. Okay, that is VA is equal to, we know 1 by 4 pi epsilon naught Q1 by R1. Okay, then electrostatic potential at a B, that is 1 by 4 pi epsilon naught having the charge Q2 by R2. Okay, we know very well VA is equal to VB. Potential is same. Okay, then substituting this, we get 1 by 4 pi epsilon naught Q1 by R1 is equal to 1 by 4 pi epsilon naught Q2 by R2. Okay, cancelling this, we get Q1 by R1 is equal to Q2 by R2. This is a valid expression. We have Q1 by R1 is equal to Q2 by R2. Okay, here it is a surface charge density. We know sigma is equal to Q by A. We can write Q is equal to sigma A. Okay, for this case Q1 is equal to sigma 1 A1. Here A1 is the area of the sphere A, that can be written as Q1 is equal to sigma 1 4 pi r 1 square. This is the area of the sphere. Okay, then we can write similarly Q2 is equal to sigma 2 4 pi r2 square. Okay, substitute in the expression 1, then we get Q1 became sigma 1 4 pi r1 square by r1, that is equal to sigma 2 4 pi r2 square by r2. Okay, cancelling this we get 4 by 4 pi cancelled, then we get sigma 1 r1 is equal to sigma 2 r2. Okay, that is equal to constant. Okay, we can write sigma r is equal to constant, that means sigma is proportional to 1 by r. Okay, if radius decreases then the surface charge density increases. Due to this reason, at the sharp point of the charged conductor the charge will leakage. Okay, then let me see the corona discharge. See, here the radius of curvature is small, here it is large. At the small region we know surface charge density is maximum. Due to that reason the electric field near this edge will be high. Due to this, it ionizes the air surrounding that. The positive ions are repelled at the sharp edge. Okay, and the negative ions are attracted towards the sharp edge. Okay, this will reduce the total charge of the conductor. Okay, that is known as action of point or current discharge. Okay, then let me see the lightning arrestor. Okay, lightning arrestor, it work on the principle of action of point or current discharge. Okay, it is used to protect the tall building from lightning. Okay, it is not reject the lightning. Okay, it will divert the lightning. Okay, here this device consists of long thick copper rod that passing from top of the building to the ground and the upper end. Okay, at the top of the building there is a rod as a sharp spike. Okay, or sharp needles, and the lower end have the of the rod that is connected to the copper plate that are buried deep into the ground. Okay, then let me see the working of the device. When the negatively charged cloud passing over the building, okay, this is a negatively charged cloud passing over the building, that induce the positive charge on the lightning arrestor. Okay, it induce see positive charge on the spike. Okay, then the induced charge density in the spike is large, that result action of point or current discharge. Okay, due to this reason there will be a current discharge. Due to the current discharge, the positive charges are repelled by the spark that sharp edges, and the negative charges are attracted. Due to that, it will ionize the air surrounding that. Then the negative charges of the clouds are neutralized. Okay, the negative charges are pushed to the spike and pass through the copper rod and safely diverted to the earth. Okay, this is a process that did by the lightning arrestor. Okay, then our next question, that is Van de Graaff generator. For this question we need to know only 4 things. Okay, first one is principle, then construction, then working, then uses. First of all, it work on the principle of electrostatic induction and action of point. We know electrostatic induction, that means producing charges without actual contact. Okay, action of point we know at the sharp edge of the charged conductor, then the charge will leakage. Okay, here it work on the 2 principle. Okay, first of all let me see the construction. Here it consists of a hollow metal spherical conductor. Okay, that is fixed on a insulating stand. These are the insulating stand. Okay, inside the sphere there will be a pulley named B, and there is a one more pulley that is C, that is on bottom. These 2 pulleys are connected with a silk belt. Okay, the pulley C is continuously run by a electric motor. Then there is a 2 comb shaped needle, that is D and E, that are placed nearby the pulleys. Okay, this is a construction. Then let me see the working. Working means we have to apply the principle. Okay, here we are applying a potential, positive potential of 10 power 4 volt. Okay, nearby the pulley C by the help of the needle D. Okay, 10 power 4 volt. near the comb D get the air get ionized, okay, due to the high potential. Here we are applying high potential, so the air between the belt and the needle will be ionized, okay. After the ionization we know there will be a splitting of ions, then the positive charges are pushed towards the belt and negative charges are attracted by the needle, okay. Then these positive charges are moving, it reach the pulley B, okay. At that place one more principle is acting, that is electrostatic induction, okay. It induce positive charges, okay, that means it induce negative charges here and positive charges on the surface of the sphere, okay. See, after that the comb E that ionizes the air between the belt and the comb, okay. That then after the negative charges are attracted by the comb and the positive charges are attracted by the comb and negative charges are repelled, then these positive charges are neutralized by this negative charge, okay. Then at the time of descending, then the belt became uncharged, okay. The positive charges are distributed on the surface of the sphere, okay. These positive charges having the potential of 10 power 7 volt, okay. There is a leakage in the device. This leakage can be prevented by enclosing the entire apparatus in a gas filled steel chamber, okay, at a high pressure, okay. This can produce a voltage of 10 power 7 volt, okay. This can be used to accelerate the positive ions, that means proton, neutron, for the purpose of nuclear disintegration, okay. For answer this question we have to know principle. What the principle is electrostatic induction and action point. Then we need to know how to draw a diagram, okay. The diagram consists of hollow metallic spherical conductor, okay, that is fixed on a insulating stand, okay. Then here it consists of two pulley that is named as B and C. B is at the center of the spherical shell or spherical conductor, and C is at the bottom of the sphere, okay. These two pulleys are connected with a silk belt. Then the pulley C is continuously run by a electric motor, okay. Then there is a two combs shaped needles, that is D and E. D is connected with a positive potential, okay. Then after applying the potential of 10 power 4 volt, the comb D will ionize the air in between the comb and the belt, okay. Then positive charges are repelled, negative charges are attracted by the needle, okay. Then the belt attract the positive charges and it will goes to the nearby the comb E. Then at that point there will be electrostatic induction, okay. Then next there will be action point, okay. Due to that the air between the needle and the belt will be ionized, then it will produce negative charge. These negative and positive charges are neutralized, then the descending belt became uncharged, okay. Then after the positive charges are distributed on the surface of the hollow sphere that having the potential of 10 power 7 volt, okay. This is used to isolate the positive ion for the purpose of nuclear disintegration, to disintegrate the nucleus. It is used to disintegrate the nucleus, okay. Okay students, first lesson is completed. You have to make a short note, that means key points for each and every questions, okay. That is a homework. You have to make key points for each and every question, okay. Thank you.